Good morning, one and all. Hi, I'm Vishal. I'm from Triple A branch. I'm from third year. So I'm here to explain about analyzing end-to-end energy consumption for digital services. Yeah, we can know in digital services, we like technology and in our surroundings and more and more, etc. We all know about it, right? Yeah. So let's dig into the subject now. So here the analyzing end-to-end energy consumption for digital services. So internet-based digital services enrich our lives in countless ways, expanding interaction with friends and colleagues, facilitating contact with businesses and government, and keeping us entertained and informed as never before imagined. But their growth and increasing ubiquity exact a cost. The considerable energy consumption it requires, along with the associated emissions of carbon dioxide that contribute to climate change. Concern over energy consumption has been a key driver behind green IT and has led to significant improvements in data center. So efficiency, what's needed now is a broad that includes IT's overall energy footprint, the total output required to provide a digital service not only at the data center level but factoring in network and end device energy usage as well. So taking this broader pros- perspective can result in better decision making in areas ranging from internet architecture design, for example, reducing central server farms by catching data in regional servers that serve as content delivery networks, to business model development, for example, creating and promoting more energy efficient tablet based versions for services previously offered primarily in PC format. Here life cycle assessment here is our methodology for determining a digital services end to end energy consumption draws on the life cycle assessment model. This technique is commonly used to measure the overall cradle to grave environmental impact of a consumer product, a packet of crisps, for example, by identifying the share of total inputs and processes involved in its manufacture, distribution, use, and disposal, and then allocating a corresponding share of associated environmental impacts for that product. So, now network transport. This involves the use of core, edge, mobile, and access network equipment to deliver the service to the end user as well as to transfer data within the delivery architecture for catching and other purposes. End user equipment, this include not only the devices used specifically to access the service but also any local access equipment such as home Wi-Fi and inverters and geysers and washing machine. All these things take so much right current to measure digital service energy consumption. For our analysis, we developed two components. The two components are a digital service assessment model. So here like the traditional life cycle assessment methodology adopts the model of a typical or average user to simplify this measurement, but the result is relatively coarse grained and risks inaccuracy in gauging total impact among all users. However, Unlike most consumer products, it allows rich end user data to be gathered and quantified straightforwardly and objectively, and thus offers the possibility for more detailed and accurate assessment than traditional analytic models. So, a fully parameterizable model for an individual user accessing the service and the resulting energy and carbon consumption. An analytic model that gathers the access accesses data regarding users behavior when accessing GNM news services, data from the analytic system regarding actual behavior of individual users or clusters of similar users can be can be parameterized for the individual model. Analytic user behavior model. The analytic module uses data from GNMS analytic system together with a set of heuristic rules to determine the likely parameters associated with a given user's access to the service. IP address can help determine likely geographic location and also whether access is taking place from a residential campus or mobile network. Device operating system and screen resolution can help identify the end user access device. So here, estimating digital service energy consumption. Here together, the individual user model and the analytic behavior module can be used to estimate an individual user's energy consumption for a given service. The service's overall energy consumption and associated carbon emissions for both estimating overall carbon footprint. The model we have described so far allows us to determine a given user's energy consumption for a specific. So here we can see the graph in this typical energy consumption in joules for a home user browsing the Guardian website for 10 minutes using a laptop. So origin data center, third party service server data center, internet network, DSLM, DSL modem, Wi-Fi router, laptop. So here we can see origin data center is between 0 to 5, and then DSL, and then third party is something 0 points. In internet network it's something 1 to 2, it varies between 1 to 2, and DSLM varies between uh, maximum in 0 1 to 5. All these things are in from 0 to 5 only. Now we can see DSL modem, Wi-Fi router. You're right, we can see Geo. We are using Geo or Interact FiberNet or Airtel broadband. We in India we are using all these things in Wi-Fi router for in home, right? We know all about these things, right? So its consumption is more. So then it is 0 to 5. It is above 5 and below 10. Yes, we in home we use laptop, and it uses more. It consumes more energy. Like it varies about it is above 15 and less than 20, but it consumes more energy than any of the other five things, right? Only for 10 minutes of consumption of energy of laptop. So we can see, right, how much energy is consumed. So here, typical energy consumption in joules for a smartphone user watching a 10-minute video Guardian website. So here we can say origin data center, third party server data center, internet network, 3G network, smartphone. Here we can see 3G network. It is the highest among them. It is touching the 120, right? We can see, and other things are 0 to 5 are below 0, are below 20, not less than that. Network is not consuming more uh, energy than the 3G network. 3G network consumes a lot of energy. So yeah, we can see in this graph or consumption in in joules, right? So, service to derive the corresponding overall carbon footprint, we combine this with data above about average carbon emissions per unit of energy, kg, CO2 e kilowatt hour, that is the emissions factor. This emissions factor varies significantly from country to country as the mix of different energy generation technology varies. For a given user or site, analytics software infers country of access based on IP address and geolocation database. We assume that both end device and access network electricity consumption occur in this country. We can't locate with a similar degree of precision either the edge and core networks or most of the content delivery networks servers involved in a given interaction. His work, described here as provided GNM with a detailed insight into the end-to-end energy and carbon footprint of its digital services and allowed GNM to become the first organization to include such findings in its annual sustainability report. We hope our work will inspire other organizations to identify the overall environmental impact of their digital services and explore approaches for reducing energy consumption. Thank you so much.